In this video, we're going to give you a guide to the basic process for two-sided machining. We're going to start with a short presentation where we discuss some of the key concepts and ideas that are associated with achieving good results when doing this. Then we'll go ahead and look at a couple of different files that have been pre-created and discuss some of these aspects within the context of the software itself. There are many ways that you can approach two-sided machining and achieve a good finished product. For the purposes of this presentation, we're really going to focus on one of those, which should work with most CNC setups, but this is only intended as a guide, and ideally what you'll do is take some of the concepts and ideas here and develop them to your specific situation and any application that you may want to use this for. To illustrate the technique, we're going to use one of the Vectric monthly projects. These are free, and they're available for download from the Vectric website. This particular project was called Cool Cubes, developed for Michael Tyler. The files for this, as well as being available on the website, were also included as part of the tutorial files, so they're in the project folder for this example. So let's start here by looking at the general concept of doing two-sided machining. The idea of this is to use the same piece of material. What we're going to do is create a set of toolpaths and cut those on one side of the material. Then we're going to take the material off the machine, we're going to flip it over, and then we'll have another set of toolpaths that we're going to cut on the other side of the material. And as you can imagine, this can be used for creating all sorts of effects. In this case, what we're doing is effectively cutting the jointing for our box on one side, and then cutting the decoration and the overall profile on the other side. That gives us the ability to have this decorative box, but also to have these joints on the back so that we can assemble it accurately. There are many other different applications for this as well. The key part of this it is essential to have exact alignment between the top and the bottom when you flip the part over for this to work correctly. This specific example we're going to show you could be done with VCarve Pro or Aspire. There's also a separate tutorial video if you are running the Aspire software so that you can review how to do two-sided machining with a 3D model. So as we already mentioned, the absolute key to making this process work is getting the correct alignment between the top side and the bottom side when we cut the two sets of toolpaths. In terms of aligning your X and Y, the typical process is going to be to start by laying out the vectors for one side of the part. It doesn't really matter whether it's the front or the back first. Typically, I think most people would probably start by designing the front though, as that's going to probably control most of your overall design. Within that, you're probably going to include some special information. For instance, you may have some dowel hole locations which we're going to drill, and we'll discuss those more in a moment. Next, you're going to make a copy of the file. So you'd lay out your front or your back, you'd save that, you'd then make a copy of the file in effect, and then edit the design, starting by mirroring the entire set of vectors, and that's going to emulate the fact we're going to flip over the material. When we do this mirroring, you make sure you use the option to flip about job center, and also you need to make a note of the direction that you mirror the vectors, whether you mirror them vertically or horizontally. As many parts are symmetrical, sometimes it can be helpful to add some text or a corner location indicator, maybe a vector in one of the corners, and that will help you to ensure you've mirrored the parts as you intended. It will give you an instant read basically of whether you've mirrored parts horizontally or vertically. Anything you can do to kind of give yourself these sort of indicators along the way reduces the chance of making an error. Once you've created the two sets of files, effectively one file for the front and one file for the back, make sure you save them as separate files. When you calculate the toolpaths, you don't want there to be any confusion between the front and the back set of data. So this is the virtual setup. From this we're going to calculate the toolpaths, but how does this relate to what we physically do on the machine? Basically, we're going to use these dowel holes to help us align the XY location of the material when we flip, so that between the front and the back, those dowels are in the same place, and that should ensure that our toolpaths are all going to be machined in the right orientation relative top and bottom. So here we can see on one side we've drilled this dowel hole. We'll talk in a moment about the options that you've got for this, whether you can machine all the way through or machine partly through. And then in the machine bed, in the sacrifice sheet on the table, you can have the same holes that you've drilled through, or you'll drill new holes and insert these dowels so that as this part is taken off it can be flipped and located in that same position. We talked about really that there are sort of two options for how you might want to go about drilling these dowel holes and placing the dowels in the sacrifice sheet. First option is to drill all the way through your material into the spoil board and use the same XY position for both sets of toolpaths. So you'll drill all the way through when you machine the first side, then you'll be able to take the material off, flip it, put two dowels into the holes that you drilled into the table, relocate your material on there, secure it so that it's attached to the table, and then you should be able to run the second set of toolpaths using the same XY location that you had when you ran the other side. There are some limitations with this method. First of all, you need to make sure you've got a tool that's long enough to drill all the way through your material and deep enough into the sacrifice sheet on the machine bed in order to locate the new dowels. Second, you'd need to ensure that you were really cutting the two sets of toolpaths without a break in sessions of cutting, so that you'd need to maintain your XY0 position in the same place when you flip the part over. If you had a situation where that maybe wasn't possible, maybe it was a very long cut and so you'd like to cut the second side the next day, you might consider option 2. Option 2 would be to drill partially through the first side, and then when you come to flip it over, what you're going to do is drill these holes into the machine bed as a new toolpath. So all you'd do is you'd relocate the machine in whatever XY position you wanted, so you could come back the next day for instance. The first operation would be to drill those two holes so you'd know that they were in the same distance and placement. Then you'd be able to insert your dowels. Now you could put your flipped piece of material in the right place and the XY0 location should be correct to execute your toolpaths. If your CNC doesn't have a sacrificial board on the bed of the machine, then you aren't going to want to drill holes in it and therefore this dowel method wouldn't work for you. An alternate idea would be to use a jig to hold the part in place when you machine the top or the bottom, and then after you flip it to hold the opposite corner in place when you machine the other side. If you were going to do this, you'd need to make sure that your material was pre-sized very accurately and was symmetrical in size around the size of the part that you were making within the software. That's the only way you're going to ensure that when you flip it and put the opposite corner in the jig, that everything is going to be located in the correct orientation between the top and the bottom of the material. So now we have a good idea how we might align the horizontal and vertical aspects of our part when we flip to top and bottom. We also still need to consider what happens with the depth of the material, or the Z-axis as we'd think of it on the CNC itself. As with the XY alignment, there are many methods that you could use to get accurate registration in the vertical axis or the Z-axis when you're flipping the part from the front to the back or vice versa. The key to this is making sure that the depths of cut that you're going to use on one side of the part are going to be in the right relative vertical position to the depths of cut that you're going to use on the other side of the part. Our preferred method of achieving this is when we're calculating toolpaths for the front of our part to set Z0 off the top of the material, as you can see in the image on the screen. When we're calculating the toolpaths for the back of our part, then we set Z0 off the machine bed, as you can see in the second picture here. What this means is that physically we're always referencing the same face of the material, whether we're cutting the front or the back. When we're cutting the front, it's going to be on the top. As we flip it over, that face will then be against the machine bed, and so that's why we set the Z0 off the machine bed when we're cutting the back. While doing this will help you minimize some of the complications you might get with having varying thickness of material, it's still really good practice to try and make sure that your material is even thickness and that you measure it and have it set up very accurately within the software itself and reference exactly on the machine tool too. So it's also important to make sure, as with all toolpaths, that you're going to set your Z0 very accurately, whether it's off the top of the material or whether it's off the machine bed. So there we've covered the sort of theory behind two-sided machining and some of the techniques that we use that we think will help you to get good results when doing this. Let's now go into the software and take a look at a couple of files that have been set up for two-sided machining so you can see some of these ideas in practice. So let's click on the option to open an existing file, and you can see that in the folder for this particular project there's a selection of CRV files which we can open in the software. There's also a PDF. The PDF is the documentation for this particular project as it was originally designed as a free download from the Vectric website. So if you want to, you can take a look at that PDF and see how the part can be put together, how it might be finished, and all the other information that Michael Tyler put together for this particular project. Here though, we're just going to take a look at some of the design files themselves. And you'll see there's actually 3 different designs for the front. There's one called Dot Cube, Snowburst and Swirl 1. We're going to open the file called Snowburst Cube _ front side.crv. So let's select that and hit open. So here you can see the vectors have been laid out for the 5 sides of the cube that are going to have decoration machined into them, or as we're thinking of it, the front side of our piece of material. Now some key elements to this, first of all, is this circle here and this circle here. These are going to represent the dowel hole locations that we're going to use for accurately aligning the part when we flip front to back. Also, you'll notice that there's some text in here. Now the text has been added as a help so that you can see which of these parts corresponds to which particular part of the cube when you do the assembly, but also these will be a really good indicator when we do our mirroring as to whether we've mirrored the part horizontally or vertically. Now there's no right or wrong order in which to do your design, whether you choose to do the front first or the back first. I think most people would typically work on their front first. So if I was doing this, I would lay out the design for the front of my part. Then when I was happy with that, I would save it. I would probably not yet start to calculate toolpaths. I'd probably like to wait until I've got both sides designed and then go ahead and start allocating the toolpaths to the vectors. So I'd do my front layout, come up to File, I'd save this file and I'd put the word front in the file name so that I know which side of the part that represents. Once I'm happy that I've got the side I'm working on laid out correctly and I've saved a copy of it, then we're ready to mirror the vectors in order to emulate this flipping process that we're going to do with the material, and then we'd be ready to do the layout for the other side of the part. To mirror it, I'm going to select all the vectors. I'm going to drag a box around them all here, come over, click on Mirror Selected Objects, and most importantly I'm going to click the option here to flip about job center, so make sure that's checked. Then it's just a case of choosing whether I intend to flip my material horizontally, so left to right in effect, or whether I intend to flip it top to bottom or vertically. You just need to make sure you make a note of whichever choice you make. In this case I'm going to flip left to right, horizontally or along the x-axis, depending how you want to think of it. So I'm going to click on the button here, flip horizontal. What's nice about having the text in the design here is I can immediately see which direction I flip this in. If I'd flip vertical, the text would now be upside down. It would also be at the top of the part as well. When we use this option to flip about job center, we do so because it means it doesn't matter whether the part we've designed is symmetrical or not. However, to make this work correctly, what you do need to make sure is that the dowel holes are going to be symmetrical around the middle of your part, or around this line that we've told the software that we're going to mirror this design over. To do that, when I laid out the vectors for those dowel holes, what I would do is draw one hole either on the left or the right or top or bottom, whichever direction I'm choosing to flip this in, and then I would use the same mirror function to create the one on the opposite side. So I'd select the dowel hole, come into the mirror function, flip about job center, and choose the appropriate option for horizontal or vertical, and that would ensure that my two dowel holes would be exactly symmetrical around the middle of the part. Therefore, I no longer need to worry about how my actual objects within the design are going to be created or positioned, because I know I should get the correct registration. Let's go ahead now and close the mirror function here. So once we've done our mirroring of the part, we've effectively created the template for what in this case is going to be the back side of our job. So the first thing you should do is always come up, go to File, Save As, and change the name of the file. In this case you'd call it back or something like that in order to differentiate it. Then you would go ahead and make changes to the design to create whichever vectors you need to control the toolpaths you wanted to machine from the back side of your piece of material. In this case I'm going to go ahead and open the file that's been created for that. So I'm going to come up, click on Open, choose All Cubes Backside.crv. So although we've got three different designs for the front, they all use the same set of toolpaths for the back in order to cut the slots that we're going to use for assembly. So we'll choose All Cubes Backside, hit Open. I don't want to save that file that we were just working with there. So within the file here you can see that Michael has created some rectangles that we're going to use to calculate the toolpaths from this side. We've still got our circles that represent the dowel holes that we're going to drill through the part. And also for reference, Michael has got the outlines of each of the panels. Now from the back side, these are not going to be toolpathed or cut out, but from a design point of view it's very useful to be able to see those in order to accurately lay out where these slots are going to be machined. And these are coloured blue, controlled by the layer that they're on. So if I click the down arrow here, you can see in the layer list that the layer that those particular vectors are on is coloured blue here. We could change that colour to something else if we wanted. And changing the colours of things on different layers can just make it a little bit easier to visualise them in the 2D view, but also to make sure that you don't select anything, in this case that's blue, in order to calculate a toolpath on it. Now for this particular example, Michael did choose to cut the toolpaths for the back first. So let's take a look at those toolpaths that were calculated for this job. I'm going to switch over to the Toolpaths tab. I'm going to go up to View, Tile the windows horizontal, so we can see the 2D view, the 3D view at the bottom here. We can see this has already got the toolpaths calculated for it. Got the alignment holes, so here we can see that that's drilling the dowel holes for us. If we double click on this, we can see it's going way past the material thickness. Material thickness is 1/2 inch. It's going to machine an additional 1/4 inch into the sacrifice sheet underneath this, and that'll leave us with the hole positions that we'd insert the dowels in when we'd remove the material and as we were flipping it to reposition it on the bed of the machine. Then we've got the pockets for the different depths of dado here. These are the slots that we're going to machine in order to allow us to assemble these different pieces together. If we want, we can go ahead and preview these. I'm just going to say preview all toolpaths, and then we can see those being cut. We can just maximize the 3D view to take a closer look if we want. So this would be the back side of the part. If we were happy with this, we could hit close and save these and output them using an appropriate post processor for our machine, and we'd be ready to take those over to the CNC machine and cut them. Let's go back to the front side now. So I'm just going to close this and also open an existing file. We'll open the one that's got the snowburst design on it. As I say, there's 3 different variations to this, plus you could make your own as well. If we hit open here, click on the icon to go across to the Toolpaths tab, we can see in this case we have a V-carve toolpath and a profile cutout. If I go up to View, Tile the windows horizontal again, we may want to draw those toolpaths in the 3D view. There we can see how they're going to work. On the surface of the material we're doing the V-carving, and then the way Michael has set these toolpaths up, it's ramping, it's taking a long ramp down into the part and then cutting them out. And we can see if we look carefully that there are some tabs on these profiles in order to hold the part in place as they're being cut out. So that will leave small pieces of material connecting each part to the original piece of stock that it's being cut from. So we could go ahead and preview these. Let's select the V-carve toolpath, click on the preview icon, preview selected toolpath. So there's our V-carving, adding our snowflake decoration there. Then second, the profile cutout, can preview that, and there we can see how that's going to look. Let's maximize the 3D view. Now, if we've accurately positioned this, then we know that when those profiles are cut out, they're going to be in the same position as those blue vector outlines were when the part was when we were in the orientation where we were looking at the back of the part. And so when we manually then remove these from the material, those slots, the dados that we cut in there, should all work and align perfectly with the other objects to allow us to assemble this. So this is just one example where we could use two-sided machining to create a part on a CNC. There are lots of other applications that you can use this methodology for, especially when you get into doing 3D work with a product like a spire. When you first look at two-sided machining, it can appear to be quite complex and like it would be hard to get good results with it. But if you try it, you'll probably find that it's much easier than it appears to be. And the real key is just making sure that you can relate the virtual alignment in the software with the physical alignment on the machine. And hopefully within this presentation we've given you some good ideas and techniques that you can use to achieve that. One nice thing with understanding this process is the fact that you can use the same set of steps whether you're making something simple or whether you're making something much more complicated. The same concepts and process are always going to apply when you're flipping the parts, just to ensure that you're getting that alignment in the X, the Y and the Z axis. And mastering the art of two-sided machining will certainly add a great deal of flexibility even to a standard 3-axis CNC machine. And that concludes this tutorial.